Hey everybody, welcome to Mitch Maths. My name is Mitch, and this video is going to be all about converting between fractions, decimals, and percentages. We're going to start off by looking at some of the more easy examples, and then we'll move on to some of the trickier ones of converting between fractions and decimals, which can be terminating or recurring. Okay, so let's start doing some converting then. So what I'm going to do is I'm going to start off with an example of a fraction, and then I'm going to turn this into a decimal, then turn that into a percentage, and then we're going to work ourselves back again. So the example of a fraction that I'm going to choose is going to be 8 over 25. Okay, so we now want to turn this into a decimal. So if you think back to one of my previous videos I did on fractions, you'll know that 8 over 25, or a fraction like this, can also be, the value can be worked out by doing 8 divided by 25, because this line is the same as a dividing line. So 8 over 25 is the same as 8 divided by 25. And if we work this out, this gives us a decimal of 0.32. And that's it. That's converting our fraction into a decimal. All you do is just divide it. You just do 8 divided by 25. So you do your numerator divided by your denominator to get your decimal. Doing this in my head, what I did, because 8 divided by 25 is quite a difficult division, so what I tend to do is I look at this and I think, right, 8 divided by 25, or 8 25ths. So this is also the same as saying 8 times 1/25. And I know that if I divide 1 by 25, I get 0.04. So, and I know that 8 times 4 is 32. So 8 times 0.04 will give me 0.32. And that's how I worked that one out in my head. Okay, so now you take this decimal, this 0.32, and we want to convert this into a percentage. So this is probably the easiest step we're going to do in this whole video. And so all we do with a percentage, to have that from a decimal, we just multiply it by 100. So in this example then, we'll take our 0.32, multiply it by 100, so we'll move our decimal point along 2 spaces, and we'll get 32. So this will become 32%. Okay, and there we go. So we've taken our fraction, started off with 8 over 25, just divided it to turn it into a decimal, gives us 0.32. Then we just multiply it by 100 to get a percentage of 32%. Okay, so now working backwards then, we now want to take our percentage and convert it back into a decimal. So to convert it the other way, we multiplied it by 100. So now what we must do is take this and then now divide it by 100 to get us back to a decimal. Okay, so we'll just divide it by 100. So if we divide it by 100, our decimal point would be sitting here. So we would just move it along back 2 spaces because it's 100, 2 zeros. So we'll take 1, 2. Decimal point would become here, just like it is in 0.32. And that's it. We've converted 32% into our decimal 0.32. Okay, so I hope none of those steps were too difficult. I'm sure hopefully these two will be really easy. Just this one could take a little bit of thought. But now what we want to do, we want to convert our decimal into a fraction. And this is where things can get a little bit tricky. So it all depends on whether our decimal is a terminating decimal or a recurring decimal. So now we'll go over some examples of those. Okay, so we'll take our example from the previous part of the video then. So we'll take our 0.32 and we want to convert it back into a fraction. And we'll start off with this because it's a good example of what we call a terminating decimal. So what I mean by a terminating decimal is that after the decimal point, there's only a finite number of numbers. So in this case, we've only got 2 numbers after the decimal point. And the other example, which we'll come to, would be a recurring decimal. And this is essentially where after the decimal point, there will be an infinite number of numbers. It will be never ending and it will never stop. But this is a good example of a terminating decimal, so this is what we'll start with. Okay? So when you approach a terminating decimal to convert back into a fraction, what you want to do is that you want to look at how many numbers there are after the decimal point. So in this case, we'll have 2. And what we want to do, we want to construct our fraction to basically have a number in the bottom here, which is a power of 10. So a power of 10s would be 10, 100, 1,000, 10,000. That has the number of zeros as there are numbers after the decimal point. So let's go and do that then. So we've got 0.32, two numbers after the decimal point. So our denominator here would be 100, okay? Two zeros for two numbers. Then on top, what we'll do is we'll essentially get rid of the 0 point and we'll just keep the numbers after the decimal point. So we'll just keep the 32. Okay? And there we go, we've done it. We've just converted this decimal into a fraction. And then of course, from our previous video as well, we looked at how we can simplify fractions. So let's do that really quickly then. So they're both even numbers, so we know we could halve them. So this one becomes 16 over 50, and then they're still even numbers, so we can halve them again. So that will become 8 over 25. And here we are, right back at our original fraction that we had at the very beginning. Okay, so I'll just show you a couple more examples of this then. So a really easy one, 0.5. Well, how many numbers are after the decimal point? Only one, so that'll be just over 10. We'll keep the 5 on top. 5 over 10 is our fraction. Simplify it down, becomes a half. Okay? How many numbers are after the decimal point becomes how many zeros there are in our power of 10. Then we'll cancel it down to our final fraction. A slightly trickier example of this then would be something like if you had a decimal such as 0.047. Okay, so this time do not get thrown off by the zeros after the decimal point. These still count as a number. So what you want to do is you want to count again how many numbers are there after the decimal point. So decimal point's here, and we've got 1, 2, 3. So that means we construct a fraction with 1000 on the bottom with 3 zeros. And then we keep all the numbers that are on top. And this time we can keep just the 47, and we can forget the 0 because 047 is just 47. So our fraction becomes this, 47 over 1000, and then we may be able to simplify that down. Well, in fact, I'm not sure we can in this case because 47 is actually a prime number. So that is our final answer. Okay, and that's how you calculate fractions from terminating decimals. You just see how many numbers there are after the decimal point. That corresponds to the number of zeros you put in your power of 10 in the denominator, and then you keep the numbers on top and then just cancel it down to get your final answer. Okay, so now we're going to be looking at the much harder example then of converting recurring decimals into fractions. So earlier in the video I said that a recurring decimal is one where the numbers after the decimal point will keep on going for infinity, forever and ever and ever. So the way these are usually denoted is you have a decimal point, 0.5 with a little dot on top, right? So this little dot means that it's recurring, and it means that this number below will go on forever. So this is the exact same as writing 0.5555555, and that would keep going forever and ever and ever. Okay, and if we had a decimal which said, say, 0.1234, and it had dots above the 1 and the 4, just like this, what this would look like, it would be 0.1234, 1234, 1234, 1234, and it would repeat these numbers between the dots. It would repeat all of that forever and ever and ever. Okay, so this is what we call a recurring decimal, when it has a section after the decimal point which keeps recurring forever and ever. And there is another type of number which has a infinite number of numbers after the decimal point, and that would be an irrational number. But unlike a recurring decimal, a irrational number will not have any recurring elements afterwards like these ones do. It will be completely random, and a good example of that would be a number like pi, which after the decimal point is completely random numbers all the way for infinity. And numbers like that, like pi, cannot be expressed as fractions either. Okay, but in this video, what we're interested in is how we convert a recurring decimal into a fraction. So let's take this one as an example then, this 0.1234 recurring. Okay, so what we're going to do is we're going to think of a letter to represent our recurring decimal. So I'm going to pick M for Mitch. So what we'll say is we'll say m equals 0.1234 recurring. So what we now want to do is we want to look at how many numbers there are after the decimal point that are recurring. In this case, there's 4. So then what we want to do is we want to multiply this whole equation by 10 to the power of 4. Okay, so we're going to multiply it by 10 to the power of 4. 10 to the power of 4 is 10,000. So we'll multiply both sides by 10,000. Okay, so we've got 10,000 m equals, so when we convert a number like this, or when we times it by a multiple of 10, what we're doing is we're moving the decimal point this way by the number of zeros that are in our power of 10. So in this one we've got 4. So we'll move our decimal point 4 places along and we'll write down the answer that we get from that. So it would be 1, 2, 3, 4, point, because don't forget this is recurring, 1, 2, 3, 4, still recurring. So don't forget this chunk goes on infinitely, so all we've done now is moved one of these chunks to the other side of the decimal point. Okay, so now what we're going to do is we're going to minus our original equation away from our new equation. Okay, so we'll take this one, we'll leave it there, and we'll write underneath it m equals 0.1234 recurring, and we want to minus these. So 10,000 m minus 1m will leave us with 9,999 m, and if we take 1234.1234 recurring and we'll minus the 0.1234 recurring away from this, what we'll be left with is just the 1,234. It'll be 0.0 because we've just taken this away from that, and they're the same. So now we have 9,999m equals 1,234. Okay, so now our m would be this divided by this. So we'll write our 1,234 over 9,999. And this is the fraction that we're left with. This is the 0.1234 recurring converted into a fraction. And that's it. I hope that made sense. We'll go through another example of this as well, a slightly different version. But if you're unsure about this, go and watch it over again. All you're doing is you're looking at how many numbers are there after the decimal point. That determines your power of 10 to multiply it by, and then you'll take off the recurring part and then divide it over to get your m. I will just show you that again with the first examples, that might be a little bit quicker. So we'll keep our m again, so m equals 0.5 recurring. We look at how many numbers there are after the decimal point that are recurring. In this case it's only 1. So in that case we only have to multiply it by 10, because 10 to the power of 1 is 10. And what we're then going to do is, so we'll say 10m equals 5.5 recurring, because multiply this by 10 shifts the decimal point this way 1. So we've still got all our 5s recurring, and then we'll minus the one we started with, the 1m equals 0.5 recurring. 10 minus 1 is 9, so we've got 9m, and then we'll take away the recurring part off of this, so it just becomes 5. So now our fraction is 5 divided by 9, and that's it, and that's our answer. 0.5 recurring as a fraction is 5 over 9. Hopefully that made a bit more sense the second time around if you didn't understand it the first time. So now we're going to show you a slightly different example where you can do this as well. Okay, so now we're going to move on to a slightly different example then of a recurring decimal, and this one could be slightly trickier, and that's because the recurring part of the decimal does not come straight after the decimal point. We've got some numbers in between which are not recurring. So this decimal then would be 0.116 and then sixes for infinity. Okay, so the way we go about turning this into a fraction then is very similar to the previous method, but slightly different. So just like the previous method then, we'll name our decimal, so we'll call it m again, okay? And we want to multiply this first by a factor of 10 that will move all of the non-recurring parts of the decimal to the other side of the decimal point, okay? So in this example, we've got two numbers here, so that means we want to multiply this by 100 to get both of those into the other side. Okay, so we'll multiply this whole equation by 100, so we'll have 100m equals now 11.6 recurring. Okay, the next part of this is we now want to multiply this again by what factor of 10 will move one whole part of the recurring section to the other side of the decimal point. Okay, so this has just got a 6 recurring, so we want to multiply this by the factor of 10, which will move one of these 6's to this side. And because it's 3 numbers deep into this side of the decimal point, we want to multiply this now by 1000. So if we do that, then we'll now have 1000m equals 116.6 recurring. Okay, so now we've got these two equations and we've got two parts which now just have decimal point 6 recurring. We can now subtract these. So we'll take the 1000m and the 100m, and they're equal to 116.6 recurring and 11.6 recurring. Okay, now you want to subtract these. So 1000m minus 100m will give 900m. Okay, and 116.6 minus 11.6 would be, so we get rid of the decimal points, and then 116 minus 11 will give 105. Okay, so now if we rearrange this for m now becomes 105 over 900. And this is our fraction. This is our fraction that is equal to 0.116 recurring. And then once you get to this point, you may be able to simplify it down. I know that this one obviously can, because both of these are multiples of 5. So you can do that as well. Okay, so I really hope that made sense. All we're doing here is we're multiplying it by a factor of 10 to move the non-recurring parts to the other side of the decimal point. Then we're doing it again to move one section of the recurring part to the other side of the decimal point, just subtracting these from each other and then rearranging for our letter, and then that will give us our final fraction. Okay, so now in the final part of this video then, we're now going to be converting the other way. So what happens if we have a fraction and we want to convert this into a recurring decimal? So this might come up sometimes in your exam, so let's go through an example of that. So the example I'm going to choose is 8 over 33. Okay, we want to convert this into a recurring decimal. So the easiest way of doing this is, remember if I said in the beginning of this video, we just divide them. If we want to convert a fraction into a decimal, we just divide this. 8 divided by 33. So if you've got a calculator, just divide it and that will give you your answer. But to do this by hand, what you can do instead is, what you want to do is you want to turn this fraction into into an equivalent fraction where the denominator is all 9s. Okay, where it's all 9s. So we want to think about what can we multiply this number by to get it into a number with all 9s. Okay, so if you think about 33 then, what we can do is we can multiply 33 by 3 to get 99. Okay, and then if we do this with the numerator as well, because remember for an equivalent fraction we must multiply the top and bottom by the same. We want to do 8 times 3, so 8 3s are 24. Okay, and now we've got this fraction 24 over 99. Okay, so when we have a fraction like this where it is just over 9s, what we then know is that it will be a recurring decimal, and whatever is on top will be the recurring part of that decimal. So this will simply become 0.24 recurring, just like this. And that's it. Okay, and another little variation on this then, if it was 8 over 333, what you'd then do is multiply that up by 3 again. So that would be 999, and that would be the same on top, 24. What you must remember now is because we've now got 3 numbers on the bottom, this means there must be 3 numbers recurring after the decimal point. So this would be 0.24, and all of this part will be recurring. The 0, 2 and the 4 will all be recurring. Okay, I hope this whole video made sense, guys. I know some of it was quite tricky in places, but if you like this video and you want to see more from Mitch Maths, then head over to my YouTube channel, like and subscribe, and thank you very much for watching, and I'll see you in the next video. Thank you very much.